Hi, I'm Matthieu Louet, a first-year master's student at the Maris program of the University Côte d'Azur. I'm doing my immersion project at the laboratory of Villefranche-sur-Mer. The subject is about the effect of climate change on Arctic benthic communities.
Arctic marine ecosystems are particularly impacted by climate change. Factors such as pH, turbidity, and nutrient availability are directly affected by melting glaciers and permafrost. One of these ecosystems is the kelp forest, which is the hotspot of biodiversity. Our work focuses on three most abundant kelp species in European Arctic and the region of Kongefelgen: Saccharina latissima, Laminaria digitata, and Alaria esculenta. For this study, scientists from the Oceanographic Laboratory of Villefranche are funded by the Prince Albert II of Monaco Foundation and the French Polar Institute. The team is composed of the project manager Steve Como and the core project team of 8 experts ranging from researchers to engineers. In France, the team and myself prepared the compiling and processing data that were foreseen to be deployed in the Arctic. For data analysis, we have used RStudio and worked on specific scripts and coding. In parallel, we have built and tested a specific structure that is designed around different scientific instruments. It consists into autonomous sensors, an ADCP that permits to measure water velocity at different heights in the water column, a light logger, and an O2 sensor used to measure the changes in O2 in the water column caused by kelp's net productivity. Once all the instruments are operational, we can deploy them in the chosen sites. It is important for the project to have different sites to compare data. 2 sites with specific characteristics have been chosen. The first site is Ansniset. It's located in the middle of the fjord in Svalbard, in a sheltered area but close to the glaciers, where turbidity is relatively elevated because of particles released by glaciers. The second site is Kongefelgen that is located at the mouth beginning of the fjord. It is therefore much more exposed to waves and wind, but the water is less turbid because it is further away from glaciers. On site, the structure has been positioned for several days, then it was retrieved and the data were downloaded from the instrument directly on the boat. To better compare our 2 sites, we also take video transects.
That's a little bit hard to follow a straight line with the ROV underwater. That's why we are setting up a transect, a 40-meter transect with a red rod just on the seabed to follow a straight line.
The images are then extracted to determine the species diversity and also to compare the percentage coverage of each species in both sites while compiling the biomass and primary productivity. We were able to collect the first measurements ever made of primary productivity of a kelp community in the Arctic. We can observe on this figure the net productivity of kelps during a 60 hours deployment in Kongefelgen. To illustrate the first findings, here with a look underwater, we see kelp's community well spread and with different density. To further extract the results, we'll need to analyze all the photographs and images, which will then provide a precise percentage coverage and biomass of kelp community. The Immersion project was a great opportunity to work on data script with sophisticated software to test and use equipment such as high-quality sensors and drone, as well as to have fantastic human interactions with scientists in France and up to 79 degrees north of latitude.
I encourage everyone to follow up on the detailed outcomes of this study that is bringing enlightenment on the climate changes that we are currently facing and its impact on this kind of ecosystem that has multiple trickle-down effects and implications.